Hello friends, in our last lecture we have started a discussion on cache memory system. In this lecture, we'll discuss some of the most important points about cache memory system. We'll discuss about different types of mapping techniques. In this lecture, we'll try to cover at least two mapping techniques. Number one, direct mapping technique, and second one, associative mapping technique. Now, what is mapping technique? What are the different type of mapping techniques we have? We'll discuss in this lecture. Let's start. So before we start the discussion, let me tell you one important concept here called mapping. What is mapping? What do you mean by mapping? As we know, our cache memory size is much smaller than our main memory. Means I cannot store everything. I cannot store all the memory blocks to my cache blocks, right? I can store only some minimum amount of information, not everything, right? Now the question is, I want to store this memory block 0. I want to store this MB0 or memory block 0 to my cache memory. The question is, where shall I store? I have 4 different spaces, right? I have 4 different cache blocks. Now this MB0 shall I map to CB0, CB1, CB2 or CB3? Who will decide that? So this is nothing but mapping. Mapping means whenever you are copying or whenever you are taking something from main memory to cache memory, this is nothing but mapping. Now the problem is, who will tell me where shall I move this MB to CB, right? There is an issue. For that, we have 3 different mapping techniques. Those techniques or those algorithm will tell you where to copy. You cannot directly copy MB0 to anywhere you want. There are some rules. So what are the rules? The first rule is called direct mapping, the easiest mapping technique. So direct mapping technique says whenever you want to copy something from your main memory, say MB0, then this MB0 can be copied to CB0 only. Please remember, MB0 can be copied to CB0 only, not in any other place. No matter how many empty blocks you have, but you have to go to CB0 only. If it is full, then also you have to wait, but you cannot put it to some other blocks. MB0 to CB0, MB1, CB1, MB2, CB2, MB3, CB3. Next, what about MB4? MB4 will go to CB0 again. MB5 will go to CB1. MB6, CB2. MB7, CB3. What about MB8? MB8 again CB0. 9, CB1. Like this it works. You understood that? So in those dedicated space only you can store the data, not everywhere. So how can you determine that space or data? How can you determine the cache block where to store? By using this simple formula. Memory block, whatever the block number is, 3, 4, whatever, mod of the number of cache blocks. Means suppose I want memory block 15. I want to know where shall I put it. So MB is 15 mod n means number of CBs, 1, 2, 3, 4. So 15 mod 4. 15 mod 4 equals to 3, right? Remainder is 3. So I know that this MB15 shall be copied to CB3 only, not in any other place. This is how it works. Fine. That means in CB0, I can have MB0, MB4, MB8 or MB12. Any one of the block I can store at a time. I cannot store everything, but any one of this I can. Similarly for CB1, MB1, MB5, MB9, MB13. For CB2, MB2 to 14. For CB3, 3 to 15. I hope you understood the basic concept of direct mapping. Now, one thing you have to be very careful. Whenever your processor asks something from memory, it never care about your cache, whether your cache is there or not, how much cache memory you have. It never care about that. Then what? Your processor needs something, it will generate the address, and it will generate the address in such a way that the information is present in main memory. It will never care whether it's there in cache or not. Let me make it more simple. Suppose this is the main memory I have. So in main memory I have total 32 memory blocks, and each block I have 4 memory words, right? That means total 127 or 128 different words are there in my main memory. Now forget about cache for few minutes. Now if your processor is asking something, some information from memory, it will generate the address based on the main memory, not based on the cache. You understood that? Means I have total 128 different words, right? Now to get any particular word from this memory, to get any particular word from this main memory, your processor will generate some address of 7 bits. You understood why 7 bits? 2 to the power 7 is 128. So this 7 bit address will be for any one of these 128 words. You understood that? It will never care about how many words are there in cache. Now this is a headache for cache, right? Because cache has very small size, but your processor is asking or generating a big address that I need, say 127th word, but I don't have that many words, right? Then how to deal with that? For that, the process is very simple. Take the same example where I have 128 words in my main memory and I have only 4 memory cache blocks, where in each block I have only 4 words. So it's small cache memory I have. Now as I told you, whenever your processor is generating some address or asking for some data, it will generate how many bits? Because I have 128 words, 7 bits. 1, 2, 3, 4, 5, 6, 7. Fine. So how to deal with that? For example, for simplicity, say your processor is asking something which is present in word number 15. I don't know what it is. Some data which is present in word number 15. Fine. Your processor is asking for word number 15. Now we know this request will be coming to cache first. Cache will check whether this is there or not. If there, then it's a hit. Otherwise, it will ask for the main memory. Now, how your cache will handle such a big address? This is how it will handle. So to get the 15th word, how your processor will generate the address? This is the address. 0001111 is nothing but 15, right? If you convert it back to decimal, this is 15. Means your processor is asking for 15th word from your main memory, and this address will be coming to cache first. Now cache will divide this address into 3 parts. In direct mapping, this is about direct mapping. In direct mapping, whenever you are sending something to cache, your cache will divide it to 3 parts. Whenever you are sending any address, it will divide it into 3 parts. The rightmost part is word, next block, next tag. Now what is word, what is block, what is tag? Let me explain. Now how many words are there in each block here? Only 4, right? So this word is nothing but to determine any one of this particular word. So how many bits I need to get any one of the word from the blocks? I need only 2 bits, right? Because 4 words are there in each block. So the last 2 bits will be coming to word 1 1. So still I have 5 more bits, right? So next is block. Block means how many blocks are there in cache? 4. To get any one of these blocks, how many bits I need? 2 only, right? So next 2 bits are reserved for block. Out of 7, 2 bits are going for word, 2 bits for block, and next 3 bits are for tag. So I hope you understood whatever I am explaining. Now see the magic. Now from this division or from this partition, your cache will easily identify that I don't know what is the data is, but I know I have to go for word number 11. Which one is the word number 11? The last word, right? 00011011. It may be anywhere, but I know the word where I have to go. Last word. Next I have block. Which block? 11. 11 means 00011011. This is the block. Now I am sure this is the block and this is the word I want. You understood that? From this particular block, because this is given by this part, and this is the particular word I am looking for because I have this word bits. Fine. Now what about this tag? I know this bit I want. Now what about this tag? Tag is very important. Why it's very important? See which block I am talking about? CB3. Now in CB3 I can have multiple memory blocks, right? Memory block 3, 7, 11, 15, then 19, 23, 27 or 31. Any one of these memory blocks can be here. But I don't want any. I want which block? MB3. Because this 15, word number 15 is there in MB3. Right? I want MB3 to be there in CB3. Then only it will be hit. I am looking for this 15. So this 000 means MB3. Tag 000 means the first possible block. What is the first possible block in CB3? MB3. 001 means next possible block, which is MB7. 010 is MB11, like this 111 is MB31. Now what is the tag here we got from this address? 000. 000 means MB3, means first possible block. So MB3 means this block. So we know the block, memory block, we know the block number, right? We know the word number, so easily we'll get it. If this block is copied, we know this is a hit. Otherwise, if it is not matching, then we will say it's a miss. I hope you understood how direct mapping works. So we have some example also. See here, I have this is the cache memory I have. This is the main memory I have. If you see, I have total 16 different blocks in main memory, and I have 4 different blocks in cache. And in each block I have 2 memory words. Now my processor has generated one address 11000. Now what I said, this 11000 will be divided into 3 parts in direct mapping. What are those? Word, block and tag. So first few bits will be reserved from the right hand side. First few bits will be reserved for word. Now how many words are there? 2 words are there in each block if you see. So how many bits I need? Only 1 bit. So 1 bit will be reserved for word. So this black color means this is for word. Next what I need? I need to get the block. So how many blocks are there? Total 4 blocks in cache. So how many bits I need to get any one of these blocks? 2 bits. So next 2 bits for block. And next I have tag. So rest whatever bits remaining after dividing, after giving it, assigning to word and block, no matter how many bits remains, all are will be in the tag only. Now only 2 bits I have, so this 2 is nothing but your tag. You understood that? So 0th word means what? So out of these 2 words, the first word I am looking for. 00 block number means from this block only I want 11. 11 means in 0th block, what are the possibilities I can store? I can store 0, I can store 4, I can store 8, or I can store 12. These are the 4 options I have, right? 15 I cannot. 15 will be there in 3. So 0, 4, 8 or 12, any one of these can be here. Now this 11, 00 means 0th block, 01 means the 4th block, 10 means 8th block, 11 means 12th block. Means this 12 block I am searching for. And from this 12 block, which word I want? The first word, 11000. So this will be here, and I am getting this things, whatever is there. See, 11000 is there. So I hope this it's clear for you. So we have one more example. Please go for it. So if you will easily understand. If you have any doubt, you can ask me. Now, if direct mapping is clear, then we'll go for the next type of mapping techniques, which is associative mapping. Trust me, this is much easier than direct mapping. So if you see, there are some drawbacks in direct mapping. What are those? Although I have enough memory space, suppose my CB naught is already full with some data, some information is already stored. After some time, I want to store CB2. So I know for CB4, I want to store CB4. I want to store MB4. So if I want to store MB4, what is the space I have? In direct mapping, I can store to CV not only, not in any other place. Maybe these places are empty, nothing is there, but still I have to wait until and unless this is free, I cannot store CV4. Because this is the dedicated place where I can store, not in anywhere. Understood that, right? So sometime it may happen that you have available memory space, but still you are waiting because you don't get the seat wherever it is reserved. Fine. To overcome from this issue, we have the next technique, which is associative mapping. So this is the easiest one. Means anyone can go anywhere. There is no restriction, no reservation, nothing. Means MB0, you want to get some place, come anywhere. You can come to CV0, CV1, CV2, CV3, anywhere you come. MB1, anywhere. MB2, anywhere. MB31, anywhere. Means anyone can occupy any space from the cache memory. If there is any empty space, it can occupy it. Fine. Then how it works, how your cache will determine which word it is looking for. See, I am taking the same example again. This 15th word your processor is looking for. So for 15, I am generating this is the address. I am generating 7 bits address because I have total 128 different words. So this is 15. Fine. Now in direct mapping, we have divided the addresses into 3 parts, right? But in associative mapping, we will divide it into 2 parts. One is for tag and one is for word. We don't have anything called block because anyone can occupy any space, right? So again, see here, from this is the address we got. So for determining any word, I need only 2 bits because 4 words are there. Same example I have taken, right? So this 1 will be reserved for word and rest everything will be reserved for tag. So how this tag works? See, suppose I want this particular things only, 15, right? So now this 15, where it will be? So it can be anywhere. Say I'm looking in CV2 whether 15 is there or not. Say I'm here, I'm looking for 15th word, whether it's there or not. How to check it? First of all, I know that the word number is 11, so last word I'm looking for. So here I'll check whether it's there or not. And in this block CB2, I can have n number of MB, right? I can have MB not, MB2. How will I make sure that this is MB3 only, not MB1 not or MB1 from this tag? If this tag is 00000 means you have to know that here MB0 is present. If it is 00001, MB1. Next 10 means MB2, 11 means MB3, and all 1 means MB31. So what is the code here? 00011. 00011 means MB3. See here, MB3 00011. And which word I am looking for? Word number 4, last word. So this is how it works. So I hope associative mapping is clear for you. Then we have an example. Just check it. The same example they have taken. This is the cache size where we have only 4 cache blocks. This is the main memory size of 16 different memory blocks. And in each block I have two words, and this is the address generated by your processor. Now can you divide this address? Yes. How many bits are necessary to get a particular word from the block? 1 bit, because two words are there in each block. So this black colored means this is the bit reserved for word. Rest all are for tag. Tag 1100. So 1100 means it will start from 0000 to 1111. Right? Total 16 blocks are there. So where is 1100? 1100 is nothing but somewhere. You check it. If this is 1111, then where it will be 1100. Once you get the memory block, you know where to go. Where to go? The word number 0. So we have two words. So word number 0 will be there. So whatever I discussed, same thing here. So that's it about associative mapping. I will suggest you to practice some more numericals on associative mapping. If there is any issue by chance, please let me know in the comment section. Thank you for watching the video.